Hello TechZone students, how are you all? In this video, we'll study about maths behind linear regression. Okay, we'll study the math behind linear regression. Okay, now see, if this is our data set, let us say this is our x-axis and this is our y-axis, and these are the points we have. Okay, these are the points we have. Now our linear regression model will draw a best fit line, isn't it? Maybe a line like this. Our linear regression model will draw a best fit line that tries to pass through all these points, but of course a straight line cannot pass through all these points, isn't it? Okay, so linear regression will draw a line such that the error is minimum. Now what do we mean by error here? See, let me draw the graph one more time. Let us say this is x, this is y. Okay, let us say we have 2 points. I am explaining the error using 2 points, and this is the best fit line. Okay, now the distance between the actual values and the predicted values, see, the point lying on this straight line is the predicted value. Okay, predicted value, and this point is the actual value. Okay, actual value. The difference of actual value and the predicted value is our error in this first case. So this is the error. Let us say that distance is d1 and here the error is d2. Okay, so this d1 is also called as residual. Okay, this is first residual and d2 is the second residual. Okay, all right. So sum of all these errors should be minimum. Okay, sum of all these errors should be minimum, and our linear regression model will draw a line in which sum of all these errors, that is d1, d2, d3, d4, d5 and so on, that should be minimum. Okay, now we need to add all these errors. Okay, and this error should be minimum, as small as possible, or as least as possible. Okay, now we directly do not add this. Okay, we square these distances, we square these errors and add. Why are we squaring? See, we'll have few points above the line and few points below the line, isn't it? If we consider the points which are below the line as negative, like this, see, the distance between the predicted value and this actual value is, let us say, -2, and the distance between this predicted value and this actual value is +2. So if we add this +2 and -2, that is d1 and d2, if we add this, we'll get 0, which indicates that there is no error at all, isn't it? But which is not the case. So to avoid this, we square this. So this +2 square will be +2 will be squared, and -2 will also be squared and added. So 2 square is 4, 2 square here is 4, so 4 plus 4 will be equal to 8. Okay, later on we'll find the square root of this 8. Okay, I hope this is clear. So this is our error, d1 square plus d2 square plus d3 square, d4 square and so on up to dn square, where n is the number of points we have. Okay, this should be as small as possible. All right, I hope this is clear. Okay, so our model will try to draw a line in which that error is as small as possible. Okay, let us say these are the points now, and this is our best fit line. Now equation of any straight line is y is equal to mx plus c, right? Okay, this is represented in many ways. Let us call it y is equal to mx plus c. We have seen this notation in the high school, isn't it? Equation of any straight line will be in this form, y is equal to mx plus c. Okay, now what is m here and what is c? C is equal to y-intercept. Okay, C is y-intercept. What is y-intercept? See, the straight line where it is touching y-axis. I'll just change the color. See, this straight line is touching y-axis here at this point, right? So this distance is called as y-intercept, and in our case we are denoting that y-intercept as c. Okay, alright. Now what is the value of m? M is the slope of line. Okay, and it is calculated using this formula, that is difference of y values divided by difference of x values, that is y2 minus y1 by x2 minus x1. Okay, the slope of this straight line, the steepness, slope of y is equal to mx plus c. Okay, now what is the value of x? X is the input value, y is the predicted value. Okay, x is the input value and y is the predicted value. That means if we give the value of y and if we know m and c and we multiply x with m and add it to c, we'll get the value of y. I'll give you one example. Let us say we have a data set like this. Okay, this is hours spent on essay. Okay, and this is the grade or the marks you got. So let this be denoted by x, let this be denoted by y. Okay, if you are spending 6 hours on an essay, let us say you are getting around 70 marks. If you are spending 8 hours, let us say you are getting 82 marks. Okay, and so on. Alright, so based on how many hours we are spending on essay, our model should predict how much grade or how many marks are we getting. Okay, so here our output is y, right? So this is the value of y. Our input is x. So if we can find the value of m and c, that is m and c, and calculate, we'll get the value of y, isn't it? So here x and y, what are this? X is the input, y is the output. All we need to do is we need to find the values of m and c. All our model does, linear regression model does, is it will calculate the values of m and c. Okay, not any m and c. Like, see, if these are our points, this will also be a line, right? Okay, this will also be a line, and this is also a line. So which line do you think is the best fit line in these 3 lines? Let us say this is first line, second line, third line. Second line is the best fit line, isn't it? So if m and c are changing, the lines will also change. If the slope is changing and if the y-intercept is also changing, obviously the lines will change, isn't it? So our model, linear regression model, what it does is it will find the values of m and c such that that line will pass very close to these points. So not just any m and c's, the values of m and c's it will find such that if we draw a line, that line should pass through almost all the points. Okay, now our aim is to find the best values of m and c. Okay, now how do we do that? We have 2 methods for that. Okay, one is direct formula. I'll write to find values of m and c. I hope you are able to understand my handwriting. To find the values of m and c, you have 2 methods. Okay, first one is using direct formula. Okay, or sometimes it is called as ordinary least squares, OLS method, ordinary least squares method. And the second one is approximation method or approximation technique. Okay, approximation technique. And I'm sure you must have heard of gradient descent. We use gradient descent in approximation technique. Okay, it's a very famous technique. Okay, it is very famous. Okay, now let us first find the values of m and c using direct formula and then using gradient descent. Alright. Okay, now see, before that let me write the linear regression function one more time. See, linear regression function or the equation of straight line is y is equal to mx plus c, isn't it? Okay, now what is the slope of the straight line? That is m. How should we find the slope of straight line? It is given by r multiplied by standard deviation of y by standard deviation of x. Okay, so what is r here? I'll write r is Pearson's correlation coefficient. Okay, we have a formula to find this, and standard deviation of y divided by standard deviation of x, that is x values and y values. Okay, so this is how we'll find the value of slope m. And how should we find y-intercept? That is c. So c will be equal to y dash minus mx dash. So here y dash is average of all the y values and x dash is average of all the x values. So to find the intercept we should know what is m also, right? And how is m calculated? Using this formula, r multiplied by standard deviation of y divided by standard deviation of x. Okay, I'll give you one example in which we'll find the value of m and c for a given data set. Alright, so let us write the formula one more time. M is equal to r multiplied by standard deviation of y divided by standard deviation of x. Okay, now r is Pearson's correlation coefficient, right? Now how is r calculated? It is calculated using this. I is equal to 1 to n. Sigma I is equal to 1 to n. If you are considering we have n points, x minus x bar multiplied by y minus y bar whole divided by, okay, square root of sigma I is equal to 1 to n again, x minus x bar whole square multiplied by sigma I is equal to 1 to n again, y minus y bar whole square. Okay, see, you need not remember these formulas. Okay, our linear regression algorithm will take care of all this. We are only learning the math behind this, how that linear regression algorithm will find the values of m and c. Alright, so this is the value of m. Okay, and what is standard deviation of y? How should we find the standard deviation of y? Square root of sigma y minus y whole square divided by n minus 1. N is the number of observations. Okay, standard deviation of y is sigma y minus y bar whole square divided by n minus 1. So y bar here is, or y dash here is the average of y values. what about standard deviation of x? Same thing, replace y values with x. Okay, sigma x minus x bar whole square by n minus 1. Of course, this is I is equal to 1 to n, and here also it is I is equal to 1 to n. Alright, let us do one thing. Let us substitute these values here. Okay, let us substitute these values here. So m is equal to r value is this, right, which is sigma I is equal to 1 to n. I hope the place will be enough. X by x minus x bar, y minus y bar, whole divided by, this is whole divided by, we have I is equal to 1 to n, x minus x bar whole square multiplied by sigma I is equal to 1 to n, y minus y bar whole square, this is square root, multiplied by standard deviation of y. So this value, right, y minus y bar whole square divided by n minus 1 here, and this is I is equal to 1 to n whole divided by this standard deviation of x. So sigma I is equal to 1 to n x minus x bar whole square divided by n minus 1. Okay, now you can consider this square root as 1 now, right? This whole square root, you can take this as 1. So this n minus 1 and n minus 1 will get cancelled. Alright, and what do we have here? This part, and this part will also get cancelled because it is inside the square, right? So let us rewrite this neatly. We'll have x minus x bar and y minus y bar, okay, whole divided by, see, we have x minus x bar square and x minus x bar square 2 times, right, and this is inside the square root. Okay, so what I mean to say here is, we'll have x minus x bar square multiplied by x minus x bar square here, okay, 2 times, right? So if you simplify, I'll write this here. This will be equal to m is equal to I is equal to 1 to n x minus x bar multiplied by y minus y bar whole divided by sigma I is equal to 1 to n x minus x bar whole square. Okay, this will be the value of m. So using this value, we'll find the slope. Using this formula, we'll find the slope. Okay, I hope this is clear. Now how should we find the value of c, that is y-intercept? Just now we saw c is equal to y dash minus m into, y dash minus m into x bar. Okay, so if we know the value of m, which we'll know by using this formula, we can substitute the value of m here. Of course, we'll know, we can calculate the value of y bar, which is average of all the y's, and x bar also we can find, which is average of all the x values. M we can find using this formula, and if we plug in all the values here, we'll get the value of c. So finally we'll have y is equal to mx plus c, isn't it? So we'll have m and we'll have c. Okay, all right. See, what I'll do now is, I'll take a data set. Okay, let us find the values of m and c now. Okay, let us say this is hours spent, okay, on essay, x values, and grades, let us say these are y values. Okay, so 6, 10, 2, 4, 6, 7, 0, 1, 8, 5, 3. These are the hours spent by different students, okay, on an essay, and they got values like this: 82, 88, 56, 64, 77, 92, 23, 41, 80, 59 and 47. Okay, so if someone is spending 6 hours, how many marks are they getting? 82. 10 hours, 88, and so on like this. Okay. Great. Now, what is the value of m? What is the formula to find the value of m? Sigma x minus x bar, okay, y minus y bar whole divided by sigma x minus x bar whole square. Alright, this one. What we'll do is, let us go ahead and find the value of m. Alright. Okay, for that we need to find x bar and y bar, right? So I have actually calculated these values. So addition of all these and divided by 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 values, that is x bar, that is mean of x is 4.72 and mean of y is 64.45. Okay, I have already calculated these values. Okay, now here x minus x bar. Let us go ahead and find x minus x bar. How should we find x minus x bar? See, for the first one, x value is how much? 6 minus x bar. X bar is how much? 4.72. 4.72. So this value will be equal to how much? Around 1.27. Okay, and few more numbers will be there. I am just rounding it off to 1.27. Okay, like that. Okay, so that is how we'll get the value of x minus x bar. So this we need to do for all the 11 points, right? Okay. Now, so 1.27, that is if you subtract 6 minus 4.72, right? And 10 minus 4.72 will give us 5.27. And the next one 2.73, that is 2 minus 4.72. Okay, I hope you are following. 0.73. The next one is 1.27. Okay, 2.27 minus 4.73 minus 3.73, 3.27, 0.27, and the last one is minus 1.73. Okay, great. We found the value of x minus x bar. Similarly, let us find the value of y minus y bar. Okay, y minus y bar. Why? Because we need that y minus y bar. Here we have y minus y bar, right? We need that. Okay, so how should we find y dash? So y is 82 from this number, right? Minus y bar or y dash is 64.45. Okay, so if we subtract, we'll get the value of y minus y bar. Alright, so like this, I'll go ahead and write all the values. Okay, so the first value will be 17.55. Okay, the next one is 23.55. Next one is minus 8.45, minus 0.45, 12.55, 27.55, minus 41.45, 23.45, 15.55, okay, minus 5.45, and minus 17.45. Okay, these are the values. See, we found y minus y dash and we found x minus x dash. Now we need to multiply and add that, right? So here in this column, what we'll do is we'll multiply these two, that is x minus x bar multiplied by y minus y bar. So this 1.27, 17.55, we'll multiply and write it here. So if you multiply 1.27 and 17.55, it will be equal to 22.33. And the next one is 124.15, multiplication of these two values. Next one is 23.06, 0.33. Next one is 15.97, 62.60, 195.97, 87.42, 50.88, minus 1.49, okay, and 30.15. Okay, these are the values. So this fourth one should be minus, I think, right? So let me just check. Plus here, minus here. Okay, great. So sigma of all this 611.36. all right. Okay, now let us go ahead and find x minus x bar whole square, because we need that also right here. X minus x bar whole square, that is squaring all these numbers, 1.27 whole square, 5.27 whole square, squaring all these numbers and adding, right? So if you take 1.27 and find the square root of that, it will be equal to 1.612. If you take 5.27 and square, it will be equal to 27.772. Now third value is 7.452, 0.53, 1.612, 5.152, 22.37, 13.912, 10.692, 0.072 and 2.249. okay, and sigma of this, that is sigma of this, is equal to how much now? 94.18. okay, let us go ahead and find the value of m. What is m? See, it was sigma x minus x bar y minus y bar divided by sigma x minus x bar whole square. So we have x minus x bar y minus y bar and its sigma, right? How much is this? 611.36 divided by, and this is 94.18. okay, I have already calculated this number. It is coming around 6.49. so this is our slope. Alright, so this is how we'll find the value of m. This is our m, 6.49. Now how should we find the value of c? C is y bar minus m into x bar, isn't it? We know the value of y bar, that is average of y, 64.45, minus value of m, just now we calculated 6.49, multiplied by value of x, for 4.72. okay, so 64.45 minus 30.63. if you multiply this 6.49 and 4.72, we'll get 30.63. and if you subtract 30.63 from 64.45, we'll get around 33.82. so this is the value of c. okay, I hope this is clear. For our data set, for this data set, our linear regression model will give us a line like this: y is equal to mx, right? See, mx plus c, right? So it will give us y is equal to, what is the value of m? It is 6.49 multiplied by x plus c. C is 33.82. We'll substitute the values of x here, like if x is equal to 6, what should be the value of the y, right? So if you substitute 6 here, we'll get something around 82. okay, so this is our hypothesis function. This is also called as hypothesis function. okay, that is, our linear regression model has predicted this line, that is y is equal to mx plus c. M here in our case is 6.49 and c here is 33.82. m is the slope and c is the y-intercept. So this is how we'll find the value of m and c using ordinary least squares. okay, now we will learn about gradient descent.